Chris Voss here from thechrisvossshow.com, thechrisvossshow.com. Anyway, we're here at Kingston Technologies. You can go to their website at kingston.com. I'm joined here with my good friend who works for Kingston, Mark Teknov.
That's pretty close.
Did I get that right?
Teknov.
Mark Teknov. And we're here to talk about the Kingston products, the HyperX. They're one of the leading manufacturers of some of the highest quality, or the highest quality, if you want to call it that, of memory technology and stuff that you can put in your computers, SSD drives, you name it. We reviewed a ton of their stuff on the Chris Voss Show. Always been very impressed with it. Be sure to search the Chris Voss Show and check out all the different reviews we've done. We've even driven cars over their SSD drives, and it was pretty cool, and they survived. And of course, the other sort of drives from the other manufacturers did not. So always been very impressed with their product. Be sure to give us a like, subscribe to us on YouTube so you can keep seeing all these great videos. We're going to make a series of videos. What we're going to do is talk to you guys today about how easy it is and how effective and how you can really build an awesome computer by building it yourself as opposed to buying some of the junk that's off the shelf. So Mark, I'll let you tell us more about Kingston and what we're going to do today.
All right, sure. So Mark Teknov, Kingston Technology, with the HyperX team. So what we do on the HyperX team, we work with the performance products from Kingston, mostly memory related, whether it be, for example, we sell DRAM memory that goes into your systems if you're doing your own builds yourself. We also sell the various SSD products under the HyperX name. This is what we call our 3K HyperX SSD, along with a variety of other things. And something that actually, we launched it last year at CES, but it's always kind of cool to talk about still is the 1 terabyte.
There's 1 terabyte in there.
Only 1 terabyte. So yeah, you could put a few things in this.
Fairly easy. So small, it's crazy.
Very easy.
So you guys make awesome SSD drives. Let's talk about what those are, because there's not a lot of people that still know what SSD is. So, they're still used to the old spin drives.
Sure.
So what's the difference between an SSD drive and a spin drive?
The main difference between them is a hard drive is using spinning media, using a platter that's very fragile. So if you drop it or if you move around too much, it may break. Where SSDs is all using chips.
It's all one piece.
So basically, it's all chips plugged onto a PCB, so that you don't have the vibration issues or problems with that.
Thin and small.
And it's a lot faster.
Yeah.
Over 500 megabytes per second, typically on read cycles.
Because it doesn't have to wait for the armature.
It doesn't have to wait for the arm. Doesn't have to wait for the spindle to spin around.
Yeah. And this is awesome. I got to tell you, since I've had the Kingston HyperX in my machines, what's really great is I survive crashes as opposed to when I used to have disk drives and didn't survive crashes because the thing was still writing the memory.
Exactly.
Where with this one, the read-write speed is much faster, so it's just boom, boom, getting it right on there. And of course, with HyperX, you guys are running with, was it read and write? There's 555 megabytes per second on the read, 510 on the write, and that's just whipping fast.
It's very
That's
fast.
like top of the standard, really, isn't it?
It is.
Yeah. So what we're going to be doing is putting together some computers. We'll talk about the different boards that are here, but this is their HyperX Kingston 240 gigabyte hard drive. You can get this in several different formats too. I love these things. They're awesome. And the cool thing about them is they don't get hot.
Right. Compared to the spinning media, you don't have those type of thermal issues that you would have. So the biggest value is faster performance and the fact that they're more dynamic. They don't have problems with vibration and
so they don't wear out quite as faster because there's no heat issues, there's no vibration issues. The awesome thing is you can pull them right out of the computer. I mean, I've had computers on for weeks. You can just turn off the computer, pull it out of the computer, and away you go. And there's just no heat issues. And if you want, go on Kingston's YouTube channel. They have a bunch of crazy videos about the destructive tests they do on these. They shoot arrows through them. I think you guys crushed them.
I think pretty much most of them
all
worked. Maybe one of them didn't quite make it, but pretty much all of them were.
Pretty much all of them. Yeah. So some really cool stuff you can find on YouTube on the Kingston channel. So we've got several different computers to look at, and we're going to talk about how important it is, how easy it is to build your own computer. I thought it would be very difficult. I thought you needed like a PhD and that I had to go to school for 2 years or something like that, and possibly go to like one of those Buddha camps over in Thailand and stuff. But it's really, really easy to take and do. It's so easy I could do it. So that tells you how easy it was. So let's talk about some of the toys you got here on the desk around.
So we have a variety of what you would call a computer today. And the word for computer has changed over the last couple of years. So Top end would be something for the gaming type of customer or a PC performance guy. May use a high-end case like this, an open face case in this case.
So we've got the
no pun intended.
We've got the HyperX memory that's in here.
So we have a HyperX memory in it. Inside of this particular machine has a gigabyte motherboard, along with a high-end $1,000 Intel processor.
Holy crap!
Only $1,000. And then a CPU cooler to make sure that when you start overclocking the CPU and the memory, you get all the heat away from the CPU as fast as possible. So you use real high-end coolers to do the same thing. So this is top of the line.
Yeah. So we're going to take a look at some overclocking stuff, how it works, all that great stuff. Look at this thing. This is crazy. Like, I can use this as a power generator for my house when the tornado hits.
Well, weekends I do that. This works out pretty well.
That's just crazy.
So then what we're going to do today is we're going to work with this machine. Okay. This one happens to be a Cooler Master case. All white seems to be a very popular color now for cases. This particular machine, again, is using a gigabyte machine, the G2 Killer, they call it. And it's using dual channel memory. Dual channel means that you need at least 2 sockets of memory installed to get the best performance out of your system. Okay. Then what we'll also do is we're going to install a CPU, which happens to be one from Intel in this particular case. Okay. And what we'll do is we'll install the CPU cooler, which happens to be this. Okay. And just as a side note, to give you an example of different kind of coolers in the market, there's extremes. If you look over here, this is a cooler from a European company. Wow. Massive fans, massive cooling.
I think that's on my Geo Metro that I drive.
You know what? It could have, it might have.
I think that's the same radiator that
I don't want to say. But if it is, I'm sorry. And this is what you would get out of the box from an Intel if you were to buy the processor directly from retail. Wow. So it's great for real simple, basic performance. It's not going to remove a lot of heat because it's not very big, versus something like this. So some examples for you.
Cool. So we got all sorts of different small cooler products, larger cooler products that are in here. And this is real important to keep everything cool so you can overclock your device. Exactly. You can really get the highest amount of performance you possibly can out of your chips. Exactly. And this is one of the other cool things about building your own board, building your own computer, is you can really make it upgradable and make it the way that you want it. A lot of what would you call them, low level or just off-the-shelf
entry-level
PCs. You can't get a lot of the different features that you can get if you build your own board. And I just went down to Fry's Electronics and just found me a nice board, bought that, used the Kingston memory, used the Kingston SSD, the HyperX memory, and put it together. And what was cool is I got all sorts of stuff on the back of it, like USB 3.0, HDMI output, that I never would have gotten if I'd bought one of the entry-level off-the-shelf computers that you get. And then the beautiful part is a lot of the boards that I had were upgradable. So I could kind of come in cheap, and then I could come in later, buy better memory, buy better, whatever to upgrade it.
Right. Another example would be the CPU. If you could spend under $100 for a CPU from either Intel or AMD to build a system with the right motherboard, and you can spend as much as $1,000 for something like this machine here. Yeah. So there's such a wide variety of pricing depending on what you're trying to accomplish and what you're trying to do. Yeah. The more overclocking you do, typically it's the more expensive CPUs. If you're just doing normal mainstream usage, you're watching streaming video online, you're doing typical processing, you don't need the $1,000 processor. But if you want to be the best of the best in your neighborhood or in that particular LAN party you go to, there are guys that bring machines like this.
Well, I know the Kingston's really huge in the gaming community and in the overclocking community. You guys do a lot of different competitions and stuff. You've been to some of your different events. And it's just really awesome. And, of course, they make the best products for that. So what do we have over here?
Okay, so going down the stack as far as size of PCs today, we have a couple examples of what people would call small form factor PCs. And what this is using a smaller main board, a motherboard. So if you look at this one, this is, for the geek in the audience, this would be considered an ATX motherboard. It's a large form factor. It's been around forever, for years. So in this system, the board is about 50% of that size. And essentially, the entire system is the same size as the motherboard. Why would you want to do that? Space, and you don't really need these giant machines if you're just doing typical gaming nowadays. So you can put everything into a small form factor case like this. And so it looks like a toy, but it has same type of memory, similar CPU, similar cooling, and again, you would either use an SSD or a hard drive. And This example's from a different case company, but same concept. Just another form factor that you can build when you're building a system. And you don't have the room for something like this.
It's got the plugs on it right here and everything.
Exactly. And same with this one. On the back side, it includes the
USBs over here.
Variety.
Wow.
So it gives you options. And then at the extreme small size in today's market,
This is cool.
is an example. Actually, we're doing right now is we're running a memory test off of this little 4x4 inch system. I'm going to swing around and go off camera
This
for a
is a
second.
gigabyte system.
So in this particular case, this is a board from a company called Gigabyte, and it's called the Bricks. Intel has something called the NUC. Zotac has something called the Z-Box, all in the same category of a 4x4 inch case. And what I'll do is I can flip it over and show you. Hopefully I won't turn off the monitor. And the difference between this and a normal size PC is we're using what you call SODIMM memory. SODIMM memory is typically used for notebooks. And in this case, for the small form factor PCs now, we're also using SODIMMs for the size.
How small those are. Those are cute. I want to take some of those home.
Yeah. If you want these, sure.
Yeah, and this is where computing's going, right?
This is where computing's going.
Going really small. There's no, to have something big like this is eventually just going to end up like that.
Eventually, the majority of the market will be going to these form factors or tablets or notebooks. And for something this size or something similar to it, you could either place it on your desk or hide it, or you can mount it on the back of your monitor.
Wow.
And everything's hidden away
And then you don't
off
have
the
to
desk.
see, you don't have your desk space taking up all this stuff.
Nice and clean, all the
crazy.
cable management's there.
Cool.
And yeah, so that's what we have as far as hardware is concerned. So what we can do is we can turn this here PC over on its side, and we can mount the CPU, the memory, and
So now this is the board. What are the most important parts if I'm building my computer? What's the most important factors I'm going to want to get the highest performance out of it on?
Okay, so it depends on what you're trying to do with that system. If you're doing gaming or high performance applications, if you're doing heavy editing or using something like Photoshop, After Effects, where you want to put a lot of video content into your system and manipulate it live, then you want the most memory and the highest performance, both CPU and graphics.
CPU and graphics.
So if you were to look at it, CPU and graphics are typically the first two things people spend on. The third item would be the memory itself.
Yeah.
So you would want that proper combination depending on what you're doing. Typically gamers nowadays, either 8 or 16 gigabytes per system. Top end guys, the guys that are doing content creation, video editing, would typically have 16 or 32 gigabytes in a system. So it just depends on what the person's
So the memory is super important. The other great thing about the memory and the SSD cards that I really like is it's just super fast in the way it boots up. It's super fast in the way it goes down. There's a distinct difference when you start up your computer and the way it runs when you're running on the SSDs, the HyperXs, as opposed to your disk drives.
Right.
Huge difference in startup speed.
On the SSD side, you get a different performance gain in this. If you're doing gaming, for load times and boot times, much faster with an SSD. When you're, as far as the actual processing, while in game or while doing some high-end performance things, the main memory is very important. And another factor nowadays is both Intel and AMD have now come out with processors in the last few years where the graphics is inside of the CPU.
Wow.
So by combining the two together, now you're at the point where the performance is almost good enough for anybody not to use discrete graphics cards. But I'm not saying that graphics cards are not needed anymore. High-end guys always use discrete graphics cards.
I was looking at this one over here. Holy crap.
Yeah, this one here actually has special piping for cooling using water inside the pipes to cool it down.
That's probably faster than my Geo Metro.
So not since I took off your radiator.
Since you took off the radiator. Well, yeah, that's right. It's not going to go far.
Now.
So, and then of course your disk drive is going to be important. You can get the HyperX in multi. What does that go to? It's 480, I think. Is the highest.
The SSDs, 480 gig is the largest that we currently manufacture. And then as far as the memory itself, the memory goes from an 8 gig kits all the way up to 64 gigabytes of memory in the system.
I'm going to break these, I think. These are check these out. These are some bad boys.
So if it doesn't work, it's because he bit into it. I had nothing to do with it. Before they were working.
Yeah, they were working before.
Yeah.
Look how bad that looks. They put like this whole thing, and this is part of it, like a cooling element or something.
Yeah, what it is it's designed basically to get around the bite marks. It's basically it's attached.
I have rabies.
Cut. You attach it where the modules, basically the chips are touching the metal frame. The heat then dissipates off the metal into the top of it. So it's a way of getting better performance for high frequency.
These things are so fast, they have to have their own heat dissipation units. That's freaking cool. That's probably why they call it Hyper Beast on the thing, huh? The Hyper Beast.
Well, the HyperX Beast is one of our names. It's there's Predator, there's Beast.
So there's different lines within the HyperX products. So there's HyperX Beast, Hyper Predator,
Beast, Predator. Genesis, and Blue. Blue's baseline for the entry-level customer.
Wow.
These are for the high end.
Cool. Yeah. We're going to put these in a machine and show you how easy
it
is.
You ready to?
Let's do it. Let's do it. I'm going to watch you.
I was going to just stand back and see you do it.
Okay. Mark, so what are we going to do now? We've got the computer all hooked up. We've got the board in the case. We've got our power supply in the case. And we got this beautiful looking Gigabyte board. This is really super nice. A G1 killer.
So let me kind of explain real quickly what we did before we got to this step.
Okay.
So it's very simple if you've never built a system before. Basically, the motherboard typically will have 9 screws, 3 on each side and 3 in the middle. You align it properly, screw them down, and then you will attach the power supply cable. The large one goes here, and then there's a small either 6 or 8 pin that sits over here, which is powering the CPU. Make sure those are plugged in, and then make sure down here in the corner you have little switches and things along this side that get plugged in.
Yep.
Make sure you always look at your manual from the manufacturer to look at what these sockets are, so you plug in the right things in the right places. Everybody does it slightly differently.
What's really nice about these power supplies, especially the high-end ones, is they have these pre-programmed plugins. You just plug them in, whether you're SATA or CPU and different peripherals. You just plug in which one you want. They usually have the pre-labeled sort of things, so you can take and plug them in. Real no-brainer. I mean, like I say, if I could figure this out how to do it the first time, just about anybody could. And it slides right in. Usually these are all made, the forms there. One thing you always want to make sure is you put your metal plate on the outside of the USB side. I'm not sure what this is called, but I always forget to put that in, then I have to do it over again.
Unfortunately, I'm famous for that. And then you take it all apart and put it back in a second time.
Okay, so we've got the part. This is our memory area. These are for our PCI.
These is PCI Express, so typically your graphics cards, or if you're doing an add-in audio card or anything of that nature, would drop in over here. Your memory would go in this location, and the CPU will go here, and then we'll place the CPU cooler on top of it.
I take the Kingston guy here, and I just
have him take the lever and lift the thing up if he works. If not,
what is this? What does this do?
That is the mascot. He's been with us for 25 years.
How much memory is in there?
I believe his name is Rex.
How much memory is in there?
You know, it depends on which version you have.
Does he look like a Rex? I think he looks like me. All right, so what I'm going to do is push this lever. Oh, I need to ground first.
So
I didn't do that.
So the first thing is
throw it away.
Is just to make sure you don't have any static. If you have any 1950s shag carpet that you walked across just now, get rid of the shag rug first of all. But secondly, just touch any one of the mounts. That way you get rid of any static electricity.
Okay, so now I move this thing. Ah! No, I'm just kidding. So I lift this up, and this will make an area room for the CPU.
The CPU itself, and then here's the CPU.
All right.
Just pick it up, and there's little tabs on either side of it that will line up with the socket over here.
Now, do this at home. This is for professionals only.
Yeah, be careful that when you put it in there that you don't bend the pins in the socket. I'm not trying to put any pressure on you.
Don't put any pressure on me. Don't put any pressure on me.
If you bend the pins, it may not work anymore. But it worked fine before you got here. So
Nurse.
We'll see what happens.
Nurse, suture. I don't know that I can really do this. Let's see. Am I doing it?
You're doing it perfectly. There's only one way to do it. There's no way to make a mistake.
That's what. Never mind.
That's perfect. Okay. Almost.
Oh,
now it's perfect.
I think it's ready.
You may not want to do that to your finger, but that's okay. You might have a little grease spot now.
Oh, well, I do.
Souvenir, actually.
Yeah.
Souvenir.
All right, that's permanent.
Yeah, just make sure it's in perfectly, which is that. And
it fit right into the area.
There's only one way to do it.
It was really. This is easier than I thought.
And then you want to lift the lever up.
Okay, you want to lift the lever up and hook it underneath that nut right there. Let me get my finger out of the way so you can see the sliding of the nut lever.
And then
this goes around there.
And the CPU is now installed. Step 1.
Bada bing!
Got a deal.
All right, I'm out of here. See.
All right, thank you for coming.
All right.
Next step is not complicated, but a little more to it. So now we have the CPU cooler.
Now let's look at this. Hold on. Look at this. Look at this. This thing. Now, can I hook this up to my washer? This will act like a water heater.
This came out of your VW bug.
This did, actually, yeah.
So this one here,
that is going to cool that little thing.
It's going to cool the CPU. So basically, we want to line it up.
How is it going to get?
Oh, it can get 85 degrees C, which
so we want to
I'll let you do the math on the calculations. It's pretty hot.
85 C.
So we actually brought a screwdriver with us. To you? Oh, screwdriver. Make it even easier for us.
Screwdriver.
And
so we're going to screw this down.
Yeah, start with one of them. Maybe get a couple.
Okay.
And then don't do it all the way. A little bit of everything.
Do the start.
Kind of like when you replace a tire. If you got a flat tire in your car, you don't want all the lug nuts all tied at the same time.
I feel like I'm on the set of MASH. Do you remember MASH? And they used to have to dab the forehead while you were...
You're on your own, buddy.
Don't we have any hot nurses for this?
Yes, but she's behind the camera. We don't want to... That's another show.
It's mostly guys in the room right now, ladies and gentlemen, so that's not going to happen. So this is one of various different ways that I can use to cool this. Now, this is separate. This cooling system is separate from the chip. You buy the chip,
right,
and then you decide what sort of coolant you want on it.
Exactly.
So I can have varying types of these things depending upon how much I plan on overclocking.
Exactly. And how much money you want to spend.
How much money I want to spend. Okay,
so
that's
if
the
you
bar.
If you bought a boxed CPU from the store, it would come with a cooler like this.
Oh, wow.
Which is perfectly fine for the average non-overclocking customer.
Sure.
But you want something like this for the performance side of it. And we need to add a fan to it. And the fan has to... Yes, we want to put a fan to blow the heat off.
Did I screw that all the way down?
Yeah, I think so.
I don't think... Did you do it?
I finished it off while you were talking, so I finished it.
I was babbling.
It's okay. So what you wanted is you want to plug in the CPU fan in that white 4-prong socket down on the bottom of the motherboard.
White 4-prong socket, and I always have to make sure I get the right...
And the reason why you want to use that particular one is the computer, when it boots up, wants to make sure a fan is spinning so that the CPU doesn't burn up and explode on you. That wasn't the right way.
Oh,
the other way. The other way.
All right.
Well, actually... Yeah, no, actually the other way.
Okay.
The other way, yeah.
Make up your mind.
You got it. It's those skinny fingers that are just getting in the
way.
way.
I have the fat fingers.
So that's perfect.
Everyone on YouTube says...
Got it in the right location.
Look at those fat fingers.
And then, basically, you just attach the cooler onto the unit.
It just snaps right on there?
It just snaps right on. Just put it on this side.
Okay. Yeah, because I still got me a HyperX memory in there.
Yeah, we want to be able to see the beautiful memory as it goes in. And then,
can't block that off.
Next step is placing the...
Oh, look at these. The HyperX Beasts. Ew. Should I bite it again? Should I test it again?
I don't know which one it was, but I'm not touching it again. You have a little tab here that you want to line up with the tabs down here.
Okay. That's this way, right?
That would be it.
Okay.
That's it.
And
if you don't, then you would probably break the socket.
Okay, now I need to pull these out, right, so that they will pop into place.
There's only on one side on this particular brand.
Now this is dual...
This is a dual channel motherboard, which means that you have 2 channels of memory that you're reading and writing to, so the performance...
And you should feel it snap right into place.
Sure, you should hear a clicking sound, yeah, exactly.
I had a clicking sound, but that was probably me breaking it.
If it doesn't boot, we know who did it.
Yeah,
it's okay, no problem.
It's not the Chris builds a computer video, it's the Chris breaks a computer video.
Well, those are almost as good sometimes. That's the sound. That's the
we're going to
pour
gasoline on this later.
That's a great sound.
Okay, so we're going to put that in.
We'll have to make sure the 3rd story door is open so you can get up there.
So you can throw it out the thing because, let's see, I'm not quite in the slot. I'm missing the hole. All right, there we go. I think we got...
Click.
Yep.
That's a sweet
There you go. Remember the old days when you have to put them in sideways? Remember that? You'd have to put them in kind of in a diagonal.
Yeah, now
crazy,
some of these boards have 8 sockets, so you can actually plug in 64 gig, which is a crazy amount of memory, but it can be done.
Yep. So there we go. I think we got it in.
Click.
And we got our HyperX Beast in. It doesn't. All right.
So, in the box, we've got everything we need, except we still need the SSD.
Oh, yeah, we need that.
So we're
not going to go far without the hard drive.
We're not going to boot up probably without it. So what we do is snap it in place, and then we'll flip it over, and we'll add the 2 cables on the backside.
Okay, we'll do it on the backside. And we got USB 3.0s there.
Some extra ones.
These are really cool, these locking things. These are really neat. These are one of the things you find with these great custom cases.
Makes it a lot easier to get things in and out.
So easy. You don't have to, I remember the old days where you used to have to screw down the side. This is the great thing about building your own computer. It's so flipping easy now. You plug stuff in, boom, whack, put it in, you got a hard drive, smack your plugs in, away you go.
Perfect.
Sweet.
So what we'll want to do is we'll see whether we can flip it around and still be on camera.
Okay.
And
you actually needed that, huh?
Basically,
I'll help hold it.
We want to plug in the power. It has a little tab on the side. Wait, this is your job.
Okay, all right.
I don't want to take the fun away from you.
Go ahead and pick it up for 1 second.
I got it.
Put that in there.
It's all yours.
All right. This is so much fun because the computer is going to be so awesome when it's done. I'm going to use it to launch space shuttles into space, and then I need a power cable.
I think that would be the data cable.
Is that data? Yeah. Am I doing it right?
Yep. Perfect.
Okay. I broke it.
She's good.
All right, and it's that easy.
And that's it. I think we can actually plug it in and see if it turns on.
Let's do that.
Let's do it. All right, now that everything's inside the system, we take the power cord, make sure it's turned off here.
Power's
good.
good.
Do that again. I'm going to flip someone off just now. Never use the middle finger. All right, so now that everything's inside the computer, take the power cord, make sure it's turned off, and we plug in the power cord. And the mouse and keyboard go in next. Actually, the actual sequence isn't that important as much as just making sure they're plugged in.
Yep.
And in this case, HDMI video out.
HDMI video out. This is the other reason that I built my own boards, is so that I get HDMI video out. A lot of the ones you could buy off the shelf, the cheap ones, wouldn't have like HDMI, and I was just like, holy crap, I want HDMI out because I want the high quality video. And of course, the new HDMIs, you can get the sound where it goes back and forth, and you have some controls. Yes. I forget what they call it, ADP or something like that. And so you can see all the wonderful different things. We've got lots of USB 3.0, which is the newest standard in USB. It's the future of what's going on. You even have digital out, and a few of these things. What are these things? These little doodads here.
Those are display port. Other display options.
Cool. So you can do other displays.
So basically, I'm going to hit the power supply. We'll set it up, and we'll turn it on.
It's smoking! No, I'm just kidding. It's smoking fast. So we want to turn this way.
Yeah, let's do it.
All right.
Okay, so what we did.
It's really quiet.
Before you came in, we already. It is, huh?
Yeah. Is it working?
It's not turned on yet.
I hit the switch.
Oh, that's just the power supply switch.
Oh.
So now we'll turn on the power switch and pray that it works. So what we did before you arrived, we installed Windows and the SSD already. So if everything works properly, and we plugged in all the cables the correct way, and fingerprints, it might still work.
Sure, let's
do
it.
Be my guest. Here's the
all right. Do you need a drum roll or a dun 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 dun?
You can always edit one in later if you'd like.
Yeah, we can do that.
I don't have
much
from.
This is everyone neat.
Let's see.
I can hear something. I'm seeing colors, and I'm not talking about the board either. Let's see. Something lit up.
Blue light on the monitor.
That's a good sign.
HDMI starting Windows. I think you might have done it right on the first try. This is pretty good stuff here.
All this help from Kingston. There we go. Wow.
Ooh. She is alive.
All right.
Congratulations.
Thank you very much, Mark. Wow. That is awesome. Now I'm taking this home.
Beautiful.
No, this is awesome. So we got the cooler in there. We got the HyperX Beast memory, which is kicking butt. We've got the HyperX SSD drive, which is going to kick butt. And of course, now I think you have some different things you're going to show us where how to monitor speed, different things of that nature.
Yeah, I can show you some examples of things that you can do with the system. The very first time that you boot it up, there's a tool that a lot of us geeks use called CPU Z, and from a site CPU ID. So what this is basically a tool that allows you to see what's inside the box. So this tells us that we're using the latest and greatest Haswell Intel i7 processor.
Wow.
Happens to be a 4770K, their top-end dual channel.
That's fast.
That's fast. And performance and frequency shows you that. For the people that know how to overclock or want to overclock, these are some of the numbers that we play with. But that would probably be, come back in again and we'll do some overclocking.
Yeah,
I'll show you how that's done.
You guys are going to be doing an overclock thing. It's at CS, and I want to see the competition. That's going to be freaking
liquid
wild.
nitrogen. You've never seen liquid nitrogen before.
No, I've never seen this done before, but I guess they have liquid nitrogen ready to go to cool the machines down when they max out the overclock and smoke comes out.
You start from the very beginning. Rather than using an air-cooled cooler, they actually put a pipe or a chimney on top of the CPU instead. They pour the liquid nitrogen in this large, and it basically starts boiling at minus 300 some odd degrees Fahrenheit, minus 300 degrees. Gets it down to a certain temperature, then start cranking the voltage and frequency.
Now you have to have it that fast to get Internet Explorer to work for Microsoft, right? No, I'm just kidding.
Crickets,
yeah. That died.
Sponsored by...
The only reason to download Internet Explorer is to...
Sponsored by Linux.
Is to download the Chrome browser.
This is a beautiful product, by the way. I really love it. So another thing you can do is you can look at the main board. Happens to be gigabyte.
Okay.
For the guy that knows and wants to make sure his machine has the latest and greatest, there's something called the BIOS in there. And it tells you which one it is, and you get the latest from Gigabyte's website and download it.
Cool.
Again, that would be another video. And then memory, we're running, it's just 1866. Basically, this number times 2 is the number that represents how fast the memory is currently running in the system.
Wow.
And these numbers tell you some background frequency speeds. Some extra detail that we can talk about another time if you like.
Okay.
So this is a tool we use, and it basically shows us what we've just installed. There's one other thing I can show you. This is what they call a torture test, Prime 95. And Prime 95 basically is a prime generator, the number 3.14 blah 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 blah. Basically you can set it up and you just start calculating using the CPU, using the memory. Why do you do it? You're using it to make sure that the memory is working properly and the CPU cooler is attached correctly.
Wow. So you can test it all.
So you can test it. So if you run this for like an hour to 2 hours and everything's running fine and there's no overheating, you know that your build is pretty stable.
And I can hear it running at a higher.
Yeah, you can hear the noise
RPMs
actually. If we stopped talking for a second, you might be able to hear the sound of it. And when I shut it down, we'll try this. I'm going to shut it down right now. We should be able to hear the fan actually finish cooling and then slow down again because it removes the heat.
There we go.
There you go. So basically what we're doing is we're maxing out the CPU to 100%. So it's basically like taking your car and putting a brick on the accelerator and running as fast as possible to make sure the system keeps running.
Cool. And I don't get pulled over by the police.
Not unless you're going really fast.
Yeah, all those warrants I have.
It has happened before.
That's serious.
But yeah, so there's a couple tools, and there's other things that you can play with, but this is just a real simple demonstration that the rig is put together correctly, booted into Windows, run a couple applications and make sure it's running. It's great.
And the cool thing is I didn't have to put in a graphics card. It was all included with the chip and
it's all
everything. It was
included
all
in
one
the
piece.
chip. Now, if you want to do something
else.
higher end, if you're running Battlefield 4 and you want to run dual SLI or some fancy high-end systems, of course, drop in a couple PCIe Express cards and go for it. But this is a good starting point.
Good starting point. And you got plenty of slots and stuff. This is the other great thing about a custom build is you can take and put in all sorts of different additional slots, everything else you might want to take and do, a Blu-ray, burner, of course more SSD memory cards from Kingston HyperX, and just crazy stuff that you can take and build. Anything else we need to cover?
I think we're doing great.
That is awesome. So we just built a computer and we put it together. We start with the shell, we put in the motherboard, and then we put in the memory card or the CPU unit, and then we put on the cooler, and then we put on the HyperX Beast memory, and so you can get those from Kingston.com. And then we pretty much plugged it in, booted it up, and it works like a charm.
Great.
So the great thing is we can make adjustments to this as we want to. We can do different upgrades depending upon the board, how you can change it as things go by, as processors get better and stuff. Depending upon the upgradability of your board, you can do a whole lot of stuff with it. And technologically wise, it's built for great stuff. So pretty awesome.
Yeah.
So be sure to go to Kingston.com. That's Kingston.com. Tell them Chris Voss sent you. Check out the HyperX product. Their HyperX Beast and Predator and all the different memory
family,
stuff.
absolutely.
Check out the HyperX SSD cards that you can take and get. I call them cards. The SSD drives, I guess. Well, you can't call them drives.
Whatever you want to call them.
Okay, whatever you want to call them is fine.
I'm happy with that.
So I really appreciate your help, Mark.
Hey, thank you.
Thank you very much.
Anytime.
You've been awesome. And I love all the toys. This is your world that you live in, that you get to play with all this stuff.
You came and saw my house, and then if I wanted to go to your house, I would go to where? Chris Voss.
To ChrisVossShow.com. Whatever. Yeah.
That's it.
So, yeah, that's it.
We practice that.
We practice that.
Thank you.
What do we practice?
Anytime.
All right. Well, thanks for coming by. The ChrisVossShow.com. The Chris Voss Show.com. The ChrisVossShow.com.